Chapter 8 covers joints, or we can also call joints articulations. These are the functional connections between bones. So before we start talking about the specific types of joints that we have throughout the human body, we need to understand what's the function. Why do we have joints to begin with? There are three main functions that joints perform. The first one probably being the most common, or when you think of a joint, you most likely think about the fact that they enable movement. So if you just think of your upper limb, for example. If our upper limbs were just, like if we look at our upper limb, our arm, the entire arm, and from shoulder all the way down to our fingertips, if it was just one solid bone, we could have skeletal muscles contract all day long, but we wouldn't be able to have all of those movements of our upper limb unless we had connections or joints between individual bones, right? One solid bone for the upper arm or for the entire arm would make no sense. So it enables movement at those joints whenever muscles exert the necessary force. So when they contract and exert force, the fact that we have joints, that enables movement, okay, of this skeleton. Another function is provide stability. So some of the joints we'll see actually do not really allow much movement, and there are some joints that don't allow any movement at all, but they are functional connections between bones, and the main function of those joints will be providing stability, and we'll see that especially in the skull. And then the third function being allowing long bones to lengthen. So we'll see that the epiphyseal plate is an example of a cartilaginous joint. And we know from previous chapters that the epiphyseal plate is located between the epiphysis and the diaphysis of a long bone. And that's where we have the lengthwise growth of long bones. And that's a type of joint. It's a connection between the epiphysis and the diaphysis within the same bone. So those are the three primary functions, or why we have joints in the human body: enabling movement, providing stability, and allowing long bones to lengthen. We can classify all joints based on their function and or their structure. And so the functional classification is how we group joints based on the movement, the range of the movement that it allows, whether it allows no movement at all, a small amount of movement, or if it's freely movable. So this is a functional classification. Joints that are classified based on the motion they allow, the movement that they do or do not allow. So if you hear the term synarthrosis, a synarthrotic joint is functionally non-movable. So no movement is allowed between these articulating bones. So synarthrotic joints would be the most stable of all the joints, right? You'll see that the more movement that a joint allows, the less stable it's going to be. The less movement it allows, the more stable it is. And then just think about that logically in your head. That makes sense, that the more movable something is, the less stable it's going to be because it allows more movement, and vice versa. So a synarthrotic joint does not allow any movement between the articulating bones. An amphiarthrosis, or an amphiarthrotic joint, will allow some movement, so a small amount of movement between articulating bones. So it's still pretty stable, but less stable than a synarthrotic joint. And then lastly, we have a diarthrosis, or a diarthrotic joint, and this is a joint that's freely movable, allowing a wide variety of movements. So diarthrotic joints would be the least stable, but allow the most movement, right? So this is how you classify joints based on their function. If I were to ask this on the test and I give you a specific type of joint and I ask you to classify it based on function, it would be one of these three terms. It would be a synarthrotic if there's no movement allowed between the two bones, amphiarthrotic joint if it's a small amount of movement, and diarthrotic joint if it's freely movable. And we'll see that later in the chapter that all synovial joints, which synovial joints make up the majority of the joints in the human body, those are all diarthrotic, meaning freely movable. next we can classify joints based on their structure, and structure meaning the type of tissue that's present. How is it structured? What type of tissue makes up that joint? Okay. And there are 3 structural classifications of joints. So all joints can be classified within one of these 3 structural classifications. The first one being fibrous, and you guessed it, the type of tissue that would make up a fibrous joint would be fibrous connective tissue. So fibrous joints are fastened together by dense, regular, collagenous connective tissue, and they lack a joint space or a joint cavity between the articulating bones. So if you think about that, so when you think dense, regular connective tissue, you should immediately think abundant collagen, densely packed together, regular, oriented in the same direction, so that it's going to be a very tough connective tissue that resists pulling forces. Really, it's going to anchor these 2 bones together, whichever bones they're connecting. And the fact that there's no joint space or no joint cavity means they're fastened very tightly together. So fibrous joints will be synarthrotic joints or amphiarthrotic joints. So they will either allow no movement at all or little movement, okay? And that makes sense based on the type of tissue that makes it up and the fact that there's no cavity between the 2 joints, okay? So fibrous joints. Cartilaginous joints, you guessed it, are composed of cartilage connective tissue. And so these bones that are connected by a cartilaginous joint are fastened together with cartilage. We'll see it will be either hyaline cartilage or fibrocartilage. Cartilaginous joints also lack a joint space or a joint cavity. So the fact that there's no joint cavity and we have a tough, yet somewhat flexible cartilage binding those bones together, we'll see that cartilaginous joints will also either be synarthrotic, meaning no movement between the 2 bones, or amphiarthrotic, meaning little movement between the 2 bones, all right? And then the last structural classification of joints is synovial. And synovial joints are diarthrotic joints. And diarthrosis means freely movable, all right? So all synovial joints are diarthrotic. That's how you would classify them based on their function, okay? Synovial is how you would classify them based on their structure. And the reason why they're called synovial joints based on their structure is because of the presence of a synovial membrane. All right, so the fact that remember when we talked about in chapter 4, membranes, a synovial membrane is a specialized type of connective tissue that secretes a synovial fluid. So the presence of a synovial membrane means that structurally it's called a synovial joint, and it's diarthrotic based on classified on function, right? And these synovial joints are going to be more complicated than fibrous or cartilaginous as far as their structure goes, and we'll see that later in the chapter. All right, and then there is a cavity, a fluid-filled cavity between the 2 bones, and that the fact that there's a joint cavity present is what allows the free movement, okay? All right, so all joints, if I gave you an example of a joint and I said classify this based on function, you would have to tell me if that joint is synarthrotic, amphiarthrotic, or diarthrotic. Okay, is it a synarthrosis joint, an amphiarthrosis, or a diarthrosis joint? Based on function. What type of movement? Does it allow no movement? Synarthrosis. A small amount of movement, amphiarthrosis. Or is it freely movable? That's a diarthrosis. Or I could ask you to classify a specific joint based on its structure, and it would be one of 3 answers. Is it composed of dense, regular connective tissue? It's a fibrous joint. Is it composed of cartilage? Then it would be a cartilaginous joint. Is there a joint cavity present and a synovial membrane present? Well, then it would be a synovial joint. So structural classification is based on the type of tissue that makes up that joint. So let's go talk about some specific examples of fibrous joints. So remember, fibrous joints these bones are held together by dense, regular, collagenous connective tissue. All right? So it's going to lend stability. The fact that it has dense, regular connective tissue, it will be very stable, but that stability comes with a price. And that price is it's going to permit little, if any, motion. So that's why it will be amphiarthrotic if it permits a little bit of movement, or synarthrotic if it does not permit any movement. And the three specific types of fibrous joints we're about to learn are sutures, Gomphosis, and Syndesmosis joints. So sutures are first, and when you learn the skeleton in Chapter 7, you had to learn a couple of sutures, and these sutures are found between the bones of the cranium, like the sagittal suture that connects the two parietal bones, the coronal suture that connects the frontal and the two parietal bones, the lambdoid suture that connects the occipital bone and the parietal bones, the squamous suture that connects the temporal bone to the parietal bones, okay? So those sutures are examples of fibrous joints. They are immovable, which immovable means, how do we classify an immovable joint based on its function? It would be called a synarthrosis joint. You find them again between the edges of bones that make up the cranium. And these are very stable joints, and that's because, okay, if we're going to find sutures between the bones of the cranium, do we want our cranial bones to be able to move freely? Do we want more movement there, or do we want stability there? We want stability, right? So we want the bones of the cranium to be very tightly fastened together to be well suited to protect the brain that's contained within. All right? Now, if you think about brain development, the fact that there are multiple bones of the cranium is good, because it allows for growth of the brain early on in development. But over time, we want those bones, once the brain has completed its growth, we want those bones to be tightly fastened together and very stable to protect the brain that's inside. So that's why we don't start off with the cranium as just being one big clump of bone, right? That would be really difficult for the brain to grow and expand rapidly very early on in development. So we want multiple bones of the cranium to allow for rapid brain growth, but we also want those cranial bones to be held together by very stable joints that will not be freely movable. And so that's why we have sutures. There's that dense, regular connective tissue holding the bones of the cranium together. They're immovable, meaning they are synarthrotic. So if I had an example of if I gave you lambdoid suture, sagittal suture, coronal suture, squamous suture, this is why you can't just learn stuff and then forget about it later on. But if I give you an example of a suture and I ask you to, tell me how to classify this specific type of joint based on, if I say based on function, you would tell me it's a synarthrotic joint, because sutures are synarthrotic. They are immovable, right? If I gave you an example of a suture and I wanted you to classify it based on structure, you would tell me fibrous. It's made up of dense, regular connective tissue, right? So those are sutures. Next type of fibrous joint is called a gomphosis. And where gomphoses are also immovable joints, so that classification, that functional classification is called synarthrotic, or it's a synarthrosis joint. And we find gomphoses in very specific locations. It's between the teeth and the bones of the jaw that contain teeth. So what bones of the facial skeleton house teeth? It's going to be the maxillary bones or the mandible. That's where we have maxillary bones would be the upper jaw, mandible would be the lower jaw. That's where we have teeth present, right? So gomphoses joints are located between the teeth and the maxillary bones, or the teeth and the mandible. Here, this is dense, regular connective tissue that's connecting, and teeth are, quote unquote, considered bones. They're very similar. They're actually harder than bones, but similar in composition, and so we consider the teeth bones, all right? Now, the dense regular connective tissue that connects the teeth to the jaw bones, either the maxillary bones or the mandible, these are given a specific term. They're called periodontal ligaments. And these periodontal ligaments form the Gomphosis joints, okay? Alveolus is the name given to the bony socket of the maxillary bones or the mandible where the teeth sit. So this structure of the maxillary bones is called an alveolus, and it's the socket where the tooth sits in. And then the tooth is anchored to that bone, that jawbone, by these periodontal ligaments, forming a Gomphosis joint, okay? So it's strong, fibrous joint. It's synarthrotic, meaning it's immovable. It makes sense. We don't want our teeth to move. We want them to be firmly anchored within the jaw bones so that we can eat properly, right? Okay, so that's a Gomphosis joint. It's an example of a Gomphosis. If I were to give you this location between the teeth and the maxillae bone, or the teeth and the mandible, and I asked what specific joint is located here, you would tell me specific joint would be a Gomphosis joint. If I gave you this as an example, a specific example of a joint, and I say classify it based on function, you would say synarthrosis because it's immovable. If I gave you this specific example of a joint and I said classify it based on structure, you would tell me fibrous because it's composed of dense, regular connective tissue, okay? So the specific type of joint located here between the teeth and the maxillae, or the teeth and the mandible, would be a Gomphosis. Classification based on function, synarthrosis. Based on structure, it would be fibrous, okay? And then the last specific example of a fibrous joint is called a syndesmosis. Okay, Syndesmosis for singular, Syndesmoses for plural. Syndesmosis joint is composed of dense, regular, collagenous connective tissue. All right, so it's going to resist pulling forces. It's going to be pretty stable and holding bones together. But syndesmosis joints do allow a small amount of movement, like a slight twisting of bones, like pivoting of bones around each other. And so the fact that it allows a small amount of movement, we classify syndesmosis joints functionally as amphithroses, okay? It's an amphiarthrotic joint, okay? Amphiarthroses. It allows for a small amount of movement. So where are some specific examples of where we find a syndesmosis joint? So I stole this from another textbook, but here we see this is the distal end of the tibia and the fibula. This is the radius and the ulna. Okay, so these are tibia and fibula are bones of the lower leg. The radius and the ulna are the bones of the forearm. All right. So if we look between the radius and the ulna and the fibula and the tibia, we see a sheet-like structure. This is an example of a syndesmosis joint. And it's given, because it's in a sheet-like structure, we give it a specific name. It's called an interosseous membrane. Interosseous, meaning between two bones. Membrane, because it's a sheet-like structure. This is an example of a syndesmosis joint. Down here, between the distal end of the tibia and the distal end of the fibula, we see a band. So this is dense regular connective tissue. This is also dense regular connective tissue. But it's not really a sheet. It's more of a rope-like structure or a band, okay? And this is given a specific name called an interosseous ligament. Interosseous, between two bones. And then ligament, lending the idea that it's a rope or a band-like structure versus a sheet-like structure. interosseous membranes and interosseous ligaments are examples of syndesmosis joints. Okay? Dense, regular, collagenous connective tissue that binds bones together, but it allows for a small amount of movement, so we classify syndesmosis joints functionally as amphiarthroses. Now, classification, if we classify syndesmosis joints based on structure, they are classified as fibrous joints. All right? So if you think about the movement of your leg and the movement of your forearm, it makes sense that these joints are going to allow a slight movement, like a pivoting or slight twisting of these bones around each other. So just a small amount of movement. They're not freely movable. They're only a small amount of movement, so they're amphiarthrotic. Okay? And this is just a slide that is summarizing the 3 specific examples of fibrous joints. Sutures, it's a specific type of fibrous joint. Sutures are classified as synarthrotic functionally and fibrous structurally. Gomphosis joints are specifically located here. They are classified as synarthrotic functionally and fibrous structurally. Syndesmosis joints, we have syndesmosis joints, we can either have interosseous membranes or interosseous ligaments. We classify them as amphiarthrotic functionally, and they are also classified as fibrous structurally. So you should be able to give me specific examples of where you find each of these joints. How do we classify them based on function? Synarthrotic, amphiarthrotic, and how do we classify them based on structure? They are all fibrous joints.